Welcome. Crave easy understanding of complex topics? Zentara.blog delivers 6 new articles daily, and now you're listening to Zentara Unlocked, Zentara.blog for your ears. For full articles and extras, visit Zentara.blog, or get your daily knowledge fix right here. Ready to discover something new? The basics of robotics, how machines are learning to move and think. Have you ever wondered how a robot vacuum cleaner knows how to avoid your furniture, or how a car can park itself? Or maybe you've seen videos of amazing robots that can walk, dance, or even explore other planets. These incredible machines are all part of the exciting world of robotics. Robotics is a branch of technology that deals with the design, construction, operation, and application of robots. It's all about creating machines that can sense the world around them, make decisions, and perform actions. In this article, we're going to dive into the basics of robotics and explore how these fascinating machines are learning to move and think, almost like us. Get ready to uncover the secrets behind these mechanical marvels. 1. What exactly is a robot? More than just movie magic. When you hear the word robot, you might picture a talking metal human from a sci-fi movie, or a cute beeping droid. While those are fun ideas, a real robot is a bit more specific. At its heart, a robot is a machine designed to carry out a series of actions automatically or by remote control. But to truly be considered a robot, especially an intelligent one, it generally needs to do 3 key things: sense, think, and act. First, it needs to sense its environment. This means it has ways to gather information about what's around it, like detecting obstacles or recognizing objects. Think of this like your own senses of sight, hearing, and touch. Second, it needs to think or process information. Based on what it senses, and the instructions it has been given, its program, the robot decides what to do next. This thinking part can range from very simple pre-programmed rules to complex artificial intelligence. Finally, it needs to act. This means it performs a physical action, like moving its arm, driving forward, or picking something up. So, while a remote-controlled toy car can move, it doesn't usually sense or think on its own, which is why we don't typically call it a robot in the same way we would a sophisticated Mars rover. The basics of robotics revolve around these core abilities, understanding how robots work by combining these elements to perform useful tasks. 2. The robot's body, nuts, bolts, and brains. Robot components. Just like humans have skeletons, muscles, and brains, robots have their own essential parts that allow them to function. Understanding these robot components is key to understanding how robots work. Let's break down the main building blocks. First, there's the body or frame. This is the physical structure that holds everything together, like a skeleton. It can be made of various materials like metal or plastic, depending on the robot's job. Then, you have actuators, which are the muscles of the robot. These are the parts that make the robot move, like electric motors that turn wheels or joints, or hydraulic systems that provide powerful lifting force. Without actuators, a robot would just be a statue. Next are sensors, which are the robot's senses. These devices collect information from the environment, which we'll explore more in the next point. A crucial component is the controller, which is the robot's brain. This is usually a computer or a tiny chip called a microcontroller that processes information from the sensors and tells the actuators what to do. Don't forget the power source. Robots need energy to operate, which usually comes from batteries for mobile robots or a direct electrical connection for stationary ones. Finally, many robots have an end effector. This is the hand or tool at the end of a robot's arm, designed for a specific task, like a gripper, a welder, or a camera. Together, these components create a functional machine capable of performing tasks. 3. Giving robots senses, how they see and feel the world. Sensors explained. For a robot to do its job properly and interact safely with its surroundings, it needs to understand what's happening around it. This is where sensors come in. They are the robot's eyes, ears, and even its sense of touch. These robot components are vital for everything from simple navigation to complex decision-making, forming a core part of how robots work and influencing robot movement. Imagine trying to walk through a room with your eyes closed. You'd bump into everything. Robots face the same challenge. Vision sensors like cameras allow robots to see their environment, recognize objects, read text, or identify colors. Some advanced robots even use 3D cameras to perceive depth. Proximity sensors are like a robot's whiskers. They can detect if an object is near without actually touching it, helping them avoid collisions. You might have these on your car to help with parking. Touch sensors, or tactile sensors, give robots a sense of touch, allowing them to know if they've made contact with an object and even how much force they are applying. This is super important for robots that need to handle delicate items. LiDAR light detection and ranging, and sonar sound navigation and ranging sensors work by sending out light or sound waves and measuring how they bounce back. This helps robots create detailed maps of their surroundings and measure distances accurately, which is essential for self-driving cars and drones. There are many other types, like temperature sensors, GPS and microphones, all providing data to the robot's controller. 4. Making robots move, from wheels to legs and arms. Robot movement and actuators. Once a robot senses its environment and its controller decides what to do, it needs to actually move. This is where actuators, the muscles of the robot, come into play. Understanding robot movement involves knowing about these crucial robot components and the principles of how robots work to navigate and interact with the world. The most common type of actuator is an electric motor. Think of the motors that spin the wheels on a robot vacuum, or the tiny motors that move the joints in a robotic arm. There are different kinds, like servo motors, which allow for very precise control of position and speed, and stepper motors, which move in exact, tiny steps. For tasks requiring a lot of strength, robots might use hydraulic actuators, which use pressurized fluid like oil to create powerful movements. You see these in large construction equipment. Pneumatic actuators are similar but use compressed air, often for faster, less forceful movements. A key concept in robot movement is degrees of freedom (DOF). This refers to the number of different ways a robot or a part of it can move. For example, your arm has many degrees of freedom. You can move your shoulder up, down, forward, backward, and rotate it. Your elbow can bend, and your wrist can tilt and turn. A simple wheeled robot might only have 2 or 3 DOF, like moving forward, backward, and turning, while a complex robotic arm might have 6 or 7 DOF, allowing it to reach almost any point in its workspace with its end effector oriented in any direction. This flexibility is crucial for performing intricate tasks. 5. The robot's brain, the controller in charge. Control systems. Every robot needs a brain to manage its actions, and this is the job of the control system, or controller. It's the central hub that connects the robot's sensors to its muscles' actuators, making sure everything works together smoothly. This is one of the most vital robot components, and is fundamental to understanding how robots work, and even how robots learn. Think of the controller as a tiny, super-fast decision-maker. It's usually a computer, ranging from a powerful one in large industrial robots, to a small microcontroller, a mini-computer on a single chip, in simpler robots, like those you might build for a school project. The controller continuously receives data from the robot's sensors. For example, a delivery robot's camera might see an obstacle, or a factory robot's touch sensor might feel a part it needs to pick up. The controller then processes this information based on its programming, the set of instructions it has been given. These instructions tell the robot what to do in different situations. After processing the sensor data, the controller sends commands to the actuators. If the delivery robot sees an obstacle, the controller tells the wheel motors to stop or turn. If the factory robot senses the part, the controller tells its arm motors to close the gripper. This entire loop, sense, process, act, happens incredibly quickly, often many times per second, allowing the robot to react to its environment in real time. Without a sophisticated control system, a robot would just be a collection of inactive parts. 6. Teaching robots their tasks. A peek into robot programming basics. How does a robot know what to do? It doesn't just magically understand its job. Humans have to give it instructions, and this is done through robot programming. Learning the basics of robot programming for beginners can be surprisingly fun and accessible, and it's a crucial step in understanding how robots learn and operate. At its core, programming a robot means creating a set of step-by-step instructions, called an algorithm, that tells the robot exactly what actions to perform and in what order. It's like writing a very detailed recipe for the robot to follow. For instance, a simple program for a robot arm might be: 1. Move to position A. 2. Open gripper. 3. Lower arm. 4. Close gripper. 5. Raise arm. 6. Move to position B. 7. Open gripper. There are many different programming languages used for robotics, from complex text-based languages like Python or C++, often used by professionals for advanced robots, to simpler visual programming interfaces. For beginners, especially younger learners, block-based programming is very popular. This involves dragging and dropping colorful blocks that represent different commands like move forward, turn left, or if sensor sees red, then stop. These blocks snap together like puzzle pieces to create a program, making it easy to understand the logic without worrying about complicated syntax. Even simple programs can make robots do amazing things, and as programmers gain experience, they can create more complex behaviors, allowing robots to navigate tricky environments or perform intricate tasks. 7. Smart robots. How machines are learning. Introduction to AI and machine learning. Some of the most exciting advancements in basics of robotics come from robots that can do more than just follow pre-programmed instructions. These are smart robots that can actually learn and adapt, and the magic behind this is artificial intelligence AI, and a specific type of AI called machine learning (ML). Understanding how robots learn is key to seeing where this technology is headed. Traditional robots are programmed for specific tasks. If something unexpected happens, they might get stuck. AI gives robots the ability to think more like humans, to make decisions, solve problems, and learn from experience. Machine learning is a way to achieve AI, where instead of programming every single step, you feed the robot lots of data examples and let it figure out patterns and rules on its own. Imagine you want a robot to recognize cats. With ML, you wouldn't write code describing what a cat looks like, pointy ears, whiskers, tail, etc. Instead, you would show the robot thousands of pictures, some of cats and some not, and tell it which ones are cats. The ML algorithms then learn the features that define a cat. After enough training, the robot can look at a new picture and decide if it's a cat with high accuracy. This same principle applies to robots learning to navigate new environments by trying different paths and seeing what works, or industrial robots learning to pick up unusually shaped objects by practicing with them. This ability to learn makes robots much more versatile and capable of handling complex, changing situations. 8. So many robots. Exploring different types of robots. Types of robots. Robots come in all shapes and sizes, designed for an incredible variety of jobs. Knowing the different types of robots helps us understand the vast reach of basics of robotics and how they impact our lives. One of the oldest and most common types is the industrial robot. You'll find these in factories, often as powerful robotic arms, doing tasks like welding, painting, assembling cars, or packaging goods. They are strong, precise, and can work 24/7. Then there are service robots, which help humans directly. This is a huge category that includes everything from robot vacuum cleaners in our homes and lawn mowing robots in our gardens, to delivery robots bringing packages, and even sophisticated surgical robots assisting doctors in operating rooms. Exploratory robots are designed to go where humans can't easily or safely go. Think of Mars rovers exploring the Red Planet, underwater robots mapping the ocean floor, or drones inspecting dangerous structures. Humanoid robots are designed to look and sometimes move like humans. While often used for research and entertainment, the goal is to create robots that can eventually work alongside us in human environments, using the same tools and navigating the same spaces. Drones or unmanned aerial vehicles, UAVs, are flying robots, used for photography, surveillance, deliveries, and agriculture. And an increasingly important category is cobots, collaborative robots, which we'll look at next. Each type is specialized for its purpose, showcasing the versatility of robotic technology. 9. Robots working with us, the rise of cobots and teamwork. Collaborative robots. For a long time, most industrial robots had to be kept in cages or behind safety barriers, because they were powerful and moved quickly, making them potentially dangerous for humans working nearby. But a new generation of types of robots, called collaborative robots or cobots, is changing that. This is an exciting part of the future of robotics. Simple explanation, and how humans and machines can work together. Cobots are designed specifically to work safely alongside humans in a shared workspace without needing extensive safety guarding. They are often equipped with advanced sensors that can detect a human's presence. If a cobot accidentally bumps into a person, it will usually stop immediately or exert only a very small, safe amount of force. This allows humans and cobots to team up, combining the strengths of both. Humans are great at problem solving, adapting to new situations, and tasks requiring fine dexterity and judgment. Cobots excel at repetitive, precise, or physically demanding tasks. For example, a human worker might perform the complex setup of a part, and then a cobot could take over to do a repetitive task like tightening screws or applying adhesive. This makes manufacturing more flexible and efficient, especially for smaller businesses that might not be able to afford traditional, fully automated systems. Cobots are also often easier to program, sometimes by simply guiding the robot's arm through the desired motions lead-through programming. This makes them more accessible and allows workers to quickly teach them new tasks, paving the way for a future where human-robot collaboration is common. Deset. The future is robotic. What's next for our mechanical friends? Future of robotics. The world of robotics is moving incredibly fast, and it's thrilling to think about what's next. The future of robotics, simple explanation, points towards robots becoming even more integrated into our daily lives, more intelligent, and more capable. The basics of robotics we've covered are the building blocks for these amazing advancements. One of the biggest drivers of future robotics is the continued development of artificial intelligence, AI, and machine learning. Robots will become better at learning from their experiences, adapting to new situations, and understanding human language and intentions more naturally. This means we'll see more capable service robots in homes and public spaces, helping with chores, providing companionship for the elderly, or assisting in retail and hospitality. In healthcare, robots will likely play even bigger roles, from performing more complex surgeries with greater precision to assisting with patient care and rehabilitation. We'll also see robots tackling bigger global challenges. They could help with sustainable agriculture by precisely monitoring crops and applying water or nutrients only where needed. Robots will be crucial for exploring extreme environments, like deep space or the ocean depths, and for disaster relief, going into dangerous areas to search for survivors or deliver supplies. Of course, as robots become more advanced, we'll also need to think carefully about important questions around safety, ethics, and how they will impact jobs. But one thing is for sure, our mechanical friends are here to stay, and they are set to make our world a very different and hopefully better place. Robotics is a fascinating field that blends engineering, computer science, and creativity. From the simple components that allow them to move and sense, to the complex AI that allows them to learn, robots are becoming increasingly sophisticated. As they continue to evolve, they will undoubtedly play an even more significant role in shaping our future. And that's a wrap for this episode of Zentara Unlocked. We hope you enjoyed it. But the journey doesn't end here. To see the visuals that accompany this discussion, read the full article at your own pace, and discover our curated list of books for further reading, with links to easily find them. Head straight over to Zentara.blog. That's Zentara.blog. While you're there, explore the other 5 new articles we published today, and check out our weekly ebooks, compiling our most popular topics. Don't forget to subscribe to Zentara Unlocked so you don't miss any of our 6 daily episodes. Thanks for listening, and keep that curiosity alive.